So we're going to be talking about complex numbers in this section, section 1.3. So complex numbers have imaginary numbers within them. So an imaginary number is one that has an I. And I just means the square root of -1. Square root of -1, if you think about it, we can't really find the square root of -1 because -1 times -1 is 1 and 1 times 1 is 1. So how do we get that to be negative? One would have to be positive and one would have to be negative, right? So that's why it's called an imaginary number. So it is the square root of -1. Here's another key concept to note is that I squared is equal to -1. We'll be using that later on. Um, so the first thing is, what is a complex number? So a complex number is one where it has a real number plus an imaginary number with it. So the A value, that's your real part, and the one that has the I, the B value, is your imaginary part. So here's our, all the numbers in the world are separated into really real ones and imaginary ones. So real ones, we have our counting numbers or natural numbers. Then we have our whole numbers, so the natural numbers with the zero with a whole. Then we have our integers where we add our negatives. Then we have our rationals or our fractions. And then we have our irrational numbers. That's those that are like pi. So if you take the square root of 2, you're going to get something that is a decimal that never ends and never repeats. So that's irrational. So these are the ones that we're used to dealing with. Now we're going to be talking about imaginary ones right now. So one of the first things I want to talk about is why. You'll hear me ask why a lot. Why in the world do we have these imaginary things? So, if any of you guys are going into engineering, you will wind up using imaginary numbers a lot. So, the I is often the direction. So, I tends to lead to direction. That's sort of a short cliff note version, spark note version of it, but it leads to the direction. So it tells you what direction a car is going before it slams into the other car. It also, if you're going into electrical engineering, it shows you which direction your electrons are moving along your circuit. So anyway, that's just a brief introduction to imaginary numbers. We're just going to do the math behind them. Once you get into your engineering courses, you will be really, really using them. So anyway, okay, so this is what I will be using on your test. We're going to have three kinds of numbers, really. We've got real numbers, so those are the ones that we're just used to dealing with, twos and -5s and a half and 0.75. Then we have purely imaginary. So those would not have any regular old numbers in them. So that would be like a 5i or a 2i, anything with an I in it. Complex numbers, you put them together. 2 plus 5i. So you put these guys and these guys together and you get your complex numbers. So I'm going to be asking you to look at each one of these and we'll decide what's the real part, what's the imaginary part, and what kind is it. So the real part in this one is -8. The imaginary part is 2i. And what kind is it? It is a complex. It has both. So 5, that's the real part. There is no imaginary part. So this is a real number. 3i, it doesn't have any real part. It has an imaginary part. So this one I call an imaginary number. And this one has pi in it. That's the real part. It does not have any. It has no imaginary part. But sometimes they'll say it does, but it's 0i, which is nothing. So I would call this a real number. Okay. Now, the reason that I mention this part right here is my lab calls these things different numbers. So for me on your test, you need to know these guys: complex, real, and imaginary. But if you want to use what my lab does, you can use that as well on my test. I don't really care. Um, but they classify complex numbers as non-real complex. So that's the ones that have to have an I in them. So I call those imaginary. But notice their non-real complex could also have a regular number and an I. So I call it complex or purely imaginary. Both of those they call non-real complex. So my lab calls real complex the ones that have no I in it or the I is 0. So, so your MyLab questions will look a little bit different than mine because all I care about is it complex? Is it real? Is it imaginary? Real has no I's in it for me. Imaginary has no real part, and complex has them both. Okay, on my test, but you might need to pull this up when you're working your MyLab problems. Anyway, okay, let's move on. Let's talk about why we're using imaginary numbers. Imaginary numbers are used so that we can work problems that you normally wouldn't be able to work. So if I covered up the negative here, we all know that the square root of 81 is just 9 times 9, so that's going to be 9. But we're going to split this into the square root of -1 and the square root of 81. And remember, we said the square root of -1 is I. So the answer to this one is just 9i. You could say plus or minus 9i if you wanted to. Eventually, we will start using plus or minus, but you could just write 9i for right now. Now this one, 55, again, this one's going to come out as an I, and the square root of 55, well, we have a problem because that's 5 times 11, and I can't take the square root of either of those, so that just stays under my house. All right, so it's just going to be I square roots of 55. And then this one, I'm still going to have my I, right? But 98, I can split. Now, I know that 2 goes into it, so if I divide 2 into 98, I'll get 49. So that really is the square root of 2 times 49. So 49 actually has a square root, so I'm going to take that out. The square root of 49 is 7. And then I can't do anything with this guy with my square root of 2. So that's just going to stay underneath the house. Now notice where I put those. I nestled that I in between my real number and my square root, which is still also a real number, but into my whole number. I should call that a whole number. Let's say into my whole number and in between my whole number and my square root. So that's where you want to put your I. If you put your I over here, sometimes it could get confused and come underneath. So that's why we don't put it there. How cute. He has an imaginary friend. Do you see his imaginary friend? All right, let's keep on going. Okay, so we're going to do some operations with complex numbers. Basically, we're going to be adding and subtracting, multiplying, dividing these guys. Okay. Actually, yes, multiplying, dividing. So we're always going to take that negative outside of the house, outside of the radican. Okay, so I'm going to take this guy out as an I and that guy out as an I, and I still have my square root of 21 times my square root of 21. So you could also think of that as I squared times 21 times 21 underneath the radical. So remember, a square root, when you take the square root of something, if you have two that are exactly the same, I call them, they get married and they come out as 1. So that 21 is just going to come out, square root of 21 times square root of 21 is just 21. And then my I squared is -1. So that's just going to be, my answer is just going to be -21. You could think of that also. Let's look at a couple of the other problems that we've done, that you've done in the past. Square root of 3 times square root of 3, that's just the square root of 9, which is 3. Let's do square root of 5 and square root of 5. That's square root of 25, and that's just 5. Are you starting to see a pattern? Square root of 7 times square root of 7 is square root of 49, which is just 7. So are you starting to see that you've got square root of 3 times square root of 3 is just 3? Square root of 5 is 5. Square root of 7 is 7. So it would make sense that the square root of 21 and the square root of negative 21 would be negative 21. But we did it the long way, right? This is the long way. I don't really care how you get from here to here. You could just look at it and know it, okay? But that does not work for this guy. You can't just look at those and know what the answer is. So there's a couple of different ways that you could do this one. I'm going to show you what I think is the easiest method. So I like to think of this 30 as 5 times 6. So underneath my radical, I'm going to have a 5 and a 5 and a 6. Okay, I also have my two negatives. So my two negatives, notice that one's going to come out as an I, and that one's going to come out as an I. So I'm going to just go ahead and say I squared there. All right, so notice that now I have these two 5s. So just like we did up here, where we have negative 5 times negative 5, that's going to come out as a 5. So the square root of 25 is 5. My 6 has to stay underneath my house because that's 2 times 3. Neither one has a square root. And then the last one is this negative, this square root of, this I squared is just a negative 1. So my answer is going to be negative 5 times the square root of 6. Now, some of y'all might have said, well, when I do it, Miss Kitts, I would do this. I would say, let's call that, I still got to put my I squared out there or you'll miss the negative. That's what most people do. But a lot of people would say, I'm going to multiply the 5 times 30 and get 150. And then I'm going to take the square root. And you can, but you're going to wind up with the same thing. And then you're dealing with this big old number. So I like to just keep it split up if I can. All right, now here's a shortcut. Square root of 42 over the square root of 3. Notice 3 goes into 42. So since 3 goes into 42, I'm going to think of that as negative 42 over negative 3, like that. And 3 goes into 42 how many times? 14 times. And my negatives cancel themselves out. So those guys are just gone. So I wind up with the square root of 14, which I can't take the square root of 14, so that's going to be my answer. So notice I can take 21. It goes into 63. So it goes into it, 3 times? And then I'm going to take my I out, my square root of negative 1. So I get square roots of 3. And then this one is actually a big old trap. And this is a trap that we're going to see a lot, and it's that plus sign. When you have a plus sign, you cannot start dividing. Okay, I call that super glue. That means these guys, circle them. These guys are stuck together. You cannot break them apart. Okay, but let's change this problem. Let's change it to Let's change it to the square root of negative 21. Times the square root of negative 3 over the square root of 7. So when there's a times there, then you can actually divide that 7 into the 21. So 7 goes into 21 3 times. So I wind up with a square root of negative 3 times the square root of negative 3, which is just negative 3. All right. So now we're going to simplify a little bit more. Let's see. Trying to get to my blues. There we are. Okay. So we have this 15 minus the square root of negative 75 over 5. The biggest trap that people usually fall into is they'll divide 5 into 15 3 times. You cannot do it That is illegal. And I'll show you why really quickly. Let's say 55 plus 5 over 5. Okay, so 55 plus 5 is what, 60? And 60 over 5, that's just 12. Okay, so the answer should be 12, but I have a lot of students that will cancel that out and say either my answer is 55, or they'll say 5 goes into 5 one time and then they'll add and get 56. But as you see, either way doesn't work. You cannot split the 55 and the 5. This thing is called, I call it super glue. Okay, so that happens a lot. Okay, so if you can't do that, what is the next step? What can we do? So we can do this part right there. I'm going to simplify that as much as I can. So I'm going to leave my 15, my 75. That's just 25 and 3. So I'm going to separate that into negative 3 times 25, or you could put the 25 first. It doesn't matter. Okay, and you can do that in your head. You don't actually have to write it out. I just write it out in our notes to help us a little bit. Okay, so I'm going to leave my 15. I'm going to leave my minus. Now notice this 25 can come out as a 5 because the square root of 25 is 5. And this negative, yes, that's going to come out as an I. So the only thing that's left underneath that house is a 3. And then we have my 5 down here. Okay, now this one, I can keep going because do you notice that we have 15, 5, and 5? All 3 of those are divisible by 5. So I'm going to go ahead and split it. I'm going to say 15 over 5 minus 5 over the square root of 3. 5i square root of 3 over 5. And then I can simplify. So that's going to be 3. And these are going to cancel out. So my final answer would be 3 minus I square roots of 3. Now, if you do not simplify, if you leave it like this, it's going to be counted wrong. Okay. And on the test, I'll give you a little bit of partial credit. My lab may not give you any partial credit for that. So let me show you one more trap. This is a MyLab trap. Okay, this is not a trap that is for my test, but in my lab, you need to know it. So on my test, notice you have a 12 on top, a 7 on top, and a 3 on bottom. Even though 3 goes into 12, it does not go into 7, so I cannot split this. Okay, one other thing I should mention is if I had a 3 right here where the 5 is, I cannot cancel the 3. I can't divide that 3 into that, if that had been a 3. I can't divide it there either, not just because of my super glue, but because this is not a square root and that is a square root. So I call these married folks and those are single folks, and they can't party together. You can never divide a married folk, a whole number, into a square root. Okay. All right. So on my test, you would just put this in the answer blank and that would be it. Okay. But in my lab, they want your answers. Most of the time, they'll say, write your answer in A plus BI form. That means they want a whole number or a fraction, and then they want it separate from the imaginary number. So we'll do exactly what I did over here where I split it up, right? Where I split it up like that. So I have this guy, and I'm going to split it up and say 12 divided by 3, and then my minus, and then 7i square roots of 5 divided by 3. And then this, the 12 divided by 3, turns into a 4, but this guy stays the same. So your answer in my lab should look like this, which to me is yuckier than what you started with. But my lab did not ask me. So I just wanted you to be aware of that because you may get the correct answer and think, why did I miss it? And it's because they asked for it in A plus BI form. All right. The last thing we're going to do in this section is just add some imaginary numbers and multiply them. Adding them is super duper simple. You just take the real parts and add them together. 4 plus a negative 5 is a negative 1. And then these guys, the i's, I've got negative 5i plus 8i. That's going to give me positive 3i. Okay, so pretty simple. Now this one has a subtraction. So really in subtraction, the only thing is there's a careless mistake that is often made. I want to make sure that you don't make it. Distribute that negative 5, that negative to the 5. Most people don't miss that. What people miss is distributing the negative to the negative 3i and turning it into a positive 3i. So that's what a lot of students miss. And you may not miss it on your homework, but you miss it when you get nervous. So just watch out for that. Once you do that, then we're just combining like terms. So that's going to give me a negative 15. And then my i's, 7i plus 3i, that's going to give me 10i. So that would be my final answer. And then this last one, usually what I do, I don't do them all in my head because sometimes that messes me up. So I'm going to distribute my negatives first and then distribute my next negative. That's an I. Supposed to be an I. That looks a little weird. Let's try that again. All right. So now that I haven't made any sign errors, I'm going to go back in and going to combine my like terms. So there's all my real numbers. 3 minus 5 plus 3, that's going to give me what? 6 minus 5. So that's going to give me 1. And then minus 4 minus 2, that's minus 6. Minus another one gives me minus 7i. And last but not least, we're going to do some multiplying. So if this was an X, you would know, oh, I'm just going to FOIL. First outside, inside, last, right? Or distribute, depending on how your Algebra 1 teacher taught you. So that's exactly what we're going to do. I'm going to take my 5 and I'm going to distribute it to the other 2. So that's 10 minus 35i. That's also first, and then the outside. Now we'll do the inside and the last. That's taking my 3i and distributing it. So that'll give me 6i minus 21i squared. Now I'm going to combine what I can, which really the only things I can combine is this in the middle. So I have 10 minus, what's that, 29i? Now, this last one, notice I have I squared. So my I squared, remember, is negative 1. So that turns out to be negative 2 times negative 1, which is a plus 2. So anytime you have an I squared, essentially you are just going to change that sign and get rid of your I squared. So the very last part is to combine my last like terms, the 10 and the 2. So that's going to give me 12 minus 29i. All right. Now this one is, some of you may have memorized how to do things that are squared, but if you did, that's awesome. But anytime you have a squared, you need to remember you can just rewrite it, okay? And then you're going to FOIL it again. So I'm going to take my 4 and distribute it. So I'll get 16 minus 20i. And then I'm going to take my negative 5 and distribute it. And I get minus 20i plus 25i squared. So my middle two are going to combine. So I'll have 16 minus 40i. And then remember we talked about this little trick. This is going to be a negative 1. So that just turns that into a negative 25. And then I combine my like terms. So my like terms are 16 minus 25. So that's going to give me what? A negative 9 maybe? Minus 40i. And that's my final answer. Let me tell you one thing though. I'm going to show you the trap. And this is the same trap that you would have had if it had been with an X. Okay, it's the same exact trap. A lot of students will just try and distribute, will just try and distribute that and get a 16 minus 25 or plus 25I squared, and they'll get the -9, but that leaves out these middle two. Okay, so whenever you have that quantity squared, you don't just distribute that too. Go ahead and write it out so that you don't forget these middle terms. So this one is essentially the same, except I've got a 6i outside of it. So I'm just going to leave my 6i for a minute, and then I'm going to work this 4 minus I times 4 minus I. So I'm going to do the blue first. 16 minus 4i minus 4i plus I squared. And I'll leave my 6i out there. I'm just going to keep simplifying. Leave my 6i out there. So that winds up being 16. Notice I'm going to, if it's okay with you guys, I'm going to go ahead and say, I know that's a -1. So a 16 minus 1 is just going to give me a 15 there. So I'm going to go ahead and do that. And then combine those guys. So that gives me minus 8i. And then finally, I'm going to distribute my 6i. So that's going to give me, what's that, 60 plus 90? 90i minus 48i squared. Now my 48i squared, remember, I squared turns into -1, so that's 90i plus 48. And we're going to write it with the actual real number first, and then my imaginary number. My notes say I should get 102i. Why is that? 16. Sorry about that. Let's see. Minus 8i. Oh, I've got 17. Negative. No, I think that's correct. Anyway, okay. All right, two more. All right, when I distribute this one, okay, so again, you might notice this is called a difference of squares. Difference of squares, because I have them, they're exactly the same, except one's a plus and one is a minus. So when I square those, or when I distribute that, I'm going to get 81. I'm going to distribute let's distribute the 9 first. So I get 81 plus, what's that, 72i. And then when I distribute the -8, -8i, I'm going to get -72i minus 64i squared. So if you notice, these guys are going to cancel themselves out. So I'm going to wind up with 81 minus a 64i squared. Now I squared is just -1. So that's 81 plus 64. That's just 145. Now notice something really cool. We started with i's and we ended with a regular real number. So this has a special, these terms are special. This one is called the conjugate of the original. It's exactly the same, except we change the number, the sign in the middle. We're going to talk more about that a little bit later, but I thought I'd just drop that little word for you to get you used to hearing it. Let's do this last one. This one's exactly the same as the others, except I'm starting with a square root of something. So the square root of 6 times the square root of 6 is just going to give me 6, and then I'll get I square roots of 6 when I finish distributing it. Then I'm going to distribute my I, so that's plus I square roots of 6. And then plus an I squared. Notice that my middles cancel again, and that's because it was a difference of squares. And I wind up with a 6 plus I squared, and my I squared is just a -1. So that's just going to give me an answer of 5. You know what? Let me go back because should be a negative I squared, right? Negative I squared, because a negative times a positive times a negative is a negative. So let me change that real quick while I'm in here. Boop. So that's going to give me, 6, what do we say, minus I squared. So 6 minus a negative 1. So my answer is actually going to be 7. All right, so that's the end of this section, 1.3, and we will start 1.4 quickly.